All right, so why I left Java for Kotlin. My name is Sam Edwards, like you said. You can find me online as HandstandSam, or you can go to handstandsam.com to check out all the blog articles. I'll probably do a recap of this in the next week or two. And yeah, I'm a Google developer expert for Android and Kotlin. That just means that I write a lot of blogs and do a lot of talks like this. And so Google kind of recognizes that. So that's pretty awesome. For work, I work at Capital One, and I'm a distinguished engineer on the identity services team. So I get to build identity SDKs that are used throughout the company. Outline of this talk. First thing, it's going to be the current state of where everything is with Java and with Kotlin. Then, of course, the live coding. This is our main section of this. And then what else is possible with Kotlin? So what are the other opportunities that we can dive into that really we can't show off in this, but is available to you? And finally, the conclusion. I love Java. I really do. So Java has always been there for me, and it was a lot of my first. So Java was my first job out of college. I learned C++ in high school just a little bit, and I learned that through my college degree, but first one in 2004 was Java when I got my first job. So you can tell how old I am based on that. My first, I did write PHP, a lot of like LAMP stack sort of things, but my first real like app that I built with the backend was using a Java backend that was deployed on the App Engine platform. And my first Android app, of course, was written in Java. And so Java has always been there for me. It got me a job. It's gotten me all of my jobs, honestly, other than some JavaScript stuff. And it's always been good to me. I love it. This is meant to be slides. So I did this once internally at Capital One, and this is like the external version that is for public use and brings out, removes any internal references. But in here, it's more of an interactive thing. If there was a crowd out there, I'm using these little emojis to kind of replicate what I would think the audience would be saying. So if this is wrong, just put that in the Q&A or whatever. We can answer that later. But if I ask who's using Java 6, there might be one guy that's like, I think I got one app at GitHub that probably still uses that, or maybe it's still deployed. Most people are off of that. Java 7, maybe a couple of people that are like, yeah, guilty. You know, I still have a few of those things. And then if you use Java 8, basically everybody else in the room is going to raise their hand up. Most of them won't be super happy about it, but yeah, it works. It's fine. Java 8's basically become the standardization of all code written in Java for the most part. And when you get into the new versions, which have been awesome, so every 6 months they're releasing new versions of Java, and you're all the way up to Java 14, which got released this spring. You're getting a lot of really cool features getting out there, but the release cycle of Java throughout the years has been really slow. And so Java kind of fell behind a little bit, and why that gave an opportunity for Kotlin to blossom. Even though Java's catching up in a lot of ways, it still has to just catch up, and Kotlin can kind of always stay ahead. If we looked at where Java, the iterations of Java came from, the very first one I interacted with was there at the end of 2004. Java 5 just got released. The thing that, I guess you all can't see my pointer on here, can you? Anyway, Java 8, the first yellow line there, if you look over, it's supported until 2030. That means that this thing has like commercial support and support by all these people to support code and platforms written in it until 2030, which is like a huge deal. That's 10 years from now, right? So to have that sort of support behind it makes people really want to stay in Java 8. The next thing down would be a maintained version would be Java 11. So that's going to be till September 2026. And then you get down to the latest version, Java 14, which was here in March. So anyway, just kind of showing in the beginning, we had 2004, 2006, and then between 6 and 7, it was 5 years. So it was that slow iteration cycle, and then another 3 years for Java 8, which is why Java's kind of slow. Anyway, more history. The main point here is Java 8, the one that everybody mostly relies on, was built in 2014. Welcome to 2020. Nobody likes 2020. 2020 has been horrible, but it's where we stand today. Hopefully we'll get through to 2021. All right, I told you why I love Java. It gave me, it helped me establish my career. It helped me build a lot of things, but then I met someone. Hi, Kotlin. So this is the definition of Kotlin. Let's kind of pick out a little bit from here. A Kotlin is a cross-platform, statically typed, general-purpose programming language with type inference. A lot of words. Basically, it's a cool programming language. The big point here is Kotlin is designed to interop fully with Java. And what else here? It just says really concise code. It mainly targets the JVM, so it runs on a Java virtual machine, but also can compile to native code, so you can run on iOS, You can run it on Kotlin native, so you can run it on any architecture you want to, CPU architecture, and then you can run it in JavaScript. So how did Android come to be in the, or sorry, how did Kotlin come to be in the Android community? So there's two really loud people, which is loud in a great way, that really were championing Kotlin, were Jake Wharton and Christina Lee. They're both Google developer experts and really got in early on Kotlin and tried to share a lot of information about it. So this first document is something that was shared internally at Square, where it was like, basically, this is why you should use Kotlin. And the big features there, you see the first three are interoperability with Java and current code bases, ability to do lambdas, which in Android at the time we couldn't do because we were stuck on Java 6 and Java 7. And then finally, null safety. So these are all amazing things. The first time I personally got exposed was this DroidCon 2016 talk by Christina Lee. I was in the room, I heard it, and basically she talked about null pointers and how you can avoid them and how it's amazing and all these things. And I said, that's really cool, but it's not supported. So, I can't use that at work. That's not stable. So it's one of those things that would be cool to explore on a side project, but it's not something that I could necessarily take to production. So it was interesting, but I didn't know what to do. But come along the next year in 2017, Google surprised us and announced that Kotlin was going to be an officially supported language because they saw these people that were very vocal in the community. They saw people really liked it, and they really liked it internally as well. So this got this big kick on the Android side by saying Google officially endorses it and will support it. As of 2019, last year, Kotlin is now the preferred language of Android app development. So if you go to any documentation or code samples now on the Google website, it'll have Kotlin first, and then it'll have Java. Don't be scared though, if you love Java, they will never drop support for Java. It's kind of like the backbone of Android and part of how it works. However, new libraries that come out and things may be written in Kotlin. So just heads up. What is Kotlin used for? This is on pusher.com, there was this kind of nice visualization I had of what Kotlin's actually used for. As I kind of said, the way that really got people to come over was for Android by this endorsement by Google to say, yes, you can use it. So Android's there. You can use it for backend. I'm seeing a lot more usage of that. We've just got some more Kotlin GDs in the program, like Josh Long, who is he's a developer relations person for Spring. So Spring is known to be your Java backend solution. You have all your dependency injection and all of everything you need for backend services with Java for that. But he's pretty much gone over to Kotlin as well. And when he does presentations at Java conferences, he does examples in Kotlin. And people kind of go along with it. So the community there's picking up. They see Kotlin, they see how well it interops and have been going with it. Another stat, last year at Open Source Conference or OSCon, Kotlin got the Breakout Project of the Year award. And so it really just kind of shows that this project has come a long way and is important. If you want to check out videos of all aspects of Kotlin, from how compilers work to how you can target multi-platform on iOS or Android, do server-side, do Android, check out the videos from Kotlin Conf last year. Unfortunately, this year, it's been postponed or delayed due to COVID, but check out the ones from last year and follow that online. This was to show that where Kotlin started. So the first line of code that was ever written for Kotlin was in 2010. They soon open sourced things, but it didn't get to a 1.0 until 2016. So when Jake Wharton wrote up that document inside of Square, that was the year before 1.0. And so that's why, it was still something that Google didn't get to, officially endorse until 2017 there. And I guess, yeah, that's good. So the reason why Kotlin can evolve so much faster than Java is because it's decoupled from the virtual machine. Right now, if you want to run Java 7 bytecode, you need a Java 7 virtual machine. If you want to Java 11 bytecode, you need a Java 11 virtual machine. And if you have a higher version, that works as well. But what's nice about Kotlin is it's Kotlin code. It goes through a compiler plugin, which then can target the Java virtual machine, or it can just target native libraries as well. So you're able to run it on any platform or machine you want it to, because the compiler takes the Kotlin code and kind of puts it where it needs to be. So that could be in the JVM or whatever. The Kotlin Foundation is something that was created by Google and JetBrains to be a non-political place. So it holds the trademarks of Kotlin. It has a lead language designer and makes sure that everything's going to be designed in a way that isn't, for the profit of one exact company. So we're getting most of our developers from Java. Today, my reason why I want to share this with you is to say why I left Java for Kotlin and maybe bring you along with me if you so choose. I'd love to answer any questions you have after this. Ping me on Twitter or wherever, and I'll point you to resources I can find. But people from Java mostly, but we're starting to pull people from other areas. This infographic is a little bit old, but it's just kind of showing where we get people from. And you know, when you find a new love, it's the little things. So the language features that people call out here, the top one here is null safety, extension functions, the Java in or out, data classes, higher order functions, type inference, multi-platform coroutines. Yeah, that's too much to take in. So these are the things that people love, but I wanted to show you what they are and why they love them. And so the best way to do that is to write some code. So let's hop into a live coding example. I think this, yeah, there we go. So that will be me. This little playground is available on GitHub. I'm going to be sharing these slides out after this talk on Twitter, on Handstand Sam. But really what it is just a basic Kotlin project. I have a playground. I have a few classes in here, but there's this playground worksheet that we're going to work on, which allows us to write code and then have it display what's going on. And yeah, let's get started. So we get in here. This is our playground. So in here, like I showed, this is a playground. We have a playground workspace, Kotlin. All right, let's get started. So each one of these sections, I just kind of have some comments, some commented out code. But the goal of this is to kind of follow along and see. I have a few notes to myself to remember what I wanted to show you, but then show you what's up. First thing is val versus var. So right here I have val Sam Edwards. If I have val Sam Edwards 2, I can make this one a var. Kind of looks the same. If I went ahead though, and I wanted to reassign one of them, so if I wanted to go ahead and say, you know, Sam Edwards is now equal to the second object, then Kotlin will get mad at me. The reason why it does is val is a final type. So once you assign the value once, you're no longer able to assign a value to it. This is very similar to how in Kotlin, in Java, you have a final keyword that you can add to any variable declaration. So that's kind of what val does. If you went ahead and change it to var, then you're able to do a reassignment. And what's nice is, you know, you're realizing this inside of your tooling, you're realizing it inside of your IDE. If you look at the reason, you know, it can literally say change to var and do it for you. So yeah, if you can, try to use final variables and use vals because it enables like functional programming, so you don't have mutable state everywhere. But vars are helpful sometimes. So if we go down here, we now have this Java user, which is Sam Edwards. And if I go ahead and use the Java syntax, I'd have, you know, Sam Edwards dot get first name. Now, actually, before we get there, let's dive into what Java user is. The Java user is a Java class that I've written. It has a constructor, which takes in a first name and last name, both final. It assigns those to private final strings. So there's 2 properties on a Java user, and there's 2 getters for it as well. Now, all these things are required because this is a private value underneath the hood. This is a constructor to pass those values in, and then these are both getters to get those out. What's cool about Kotlin as well is I can't use keyboard shortcuts. What's cool is you don't have to use that new keyword. It's just a little bit of boilerplate, but it's not there. You just say the type and you start it up. You also don't need semicolons. Kotlin doesn't hate you if you put a semicolon. It just kind of says you didn't need this, so you don't have to put them there. It's okay. But yeah, if you're going to access this object in Java, you do, you know, Sam Edwards dot get first name. But it's going to be this little, actually, let's just run it. So there's this little button in the corner of a playground or a worksheet. I go ahead and play it, and then on the side here, I'll get a little console output at the bottom, but then I'll get the value, like what's been generated on the right. So Sam Edwards dot get first name gives me this. But one thing that's really great about Kotlin is a big influence in the people that are building it right now are inside of IntelliJ, which is the company that, you know, is helping build Kotlin and have engineers to do that. But also they build the IntelliJ IDE, IntelliJ IDEA, which is like the most popular development platform that there is for developing Java. Also Android Studio, which is the tool that Google makes to develop Android apps, is actually built on top of the community edition of this. So if you're using Android Studio or you're using this, it's the exact same thing underneath the hood. But what it does when you use one of those things is you get tooling. So I can use this autocomplete thing on my keyboard. It tells me like, why do I have this yellow squiggly? And it's because it wants me to use property syntax or access syntax. I click on it, and now it's Sam Edwards first name. It does look a lot better. Yeah, so get first name, and then we can just switch it over, and there it is. Boop. So if we look into it, if I went back to this version, if I clicked in, I go directly to this get first name function, which is on my Java class. If I went ahead and went back, I change it to just first name, then I knew how to type. I clicked into it. It's literally calling the exact same method. So this is that example of why Java interop is so amazing, where this class is already in Java. I'm able to call it by the Java name if I want, but I can also use my pretty Kotlin syntax to just use the variable name, and it knows underneath the hood, it will call the getter. So I really like that. This syntax just makes a lot of sense to me. So yeah, val versus var and your interop with Java. Moving on. The nullability in the type system. So that was one of the highest things up there, is the nullability is like a big thing in Java and saves you from those dreaded null pointer exceptions. So I have two examples below to show this. I have a non-null string and a nullable string. As you can see, there's one difference between these, other than the value that's assigned, is this type. So in this case, it is a string. In this case, it is a nullable string. So let's look at how that works. If I take this string type here and I assign it to null, then it will tell me no. So if I look at what it's telling me to do, it says, hey, are you sure? Do you want to change this to a nullable string so you can set it to null? I can say yes, and now it's nullable. Kind of how it works there. If I went ahead now and, yeah, pretty much I can operate it on let's see, yeah, so non-null string is that, nullable string is that. So this, what's cool about the nullable types is it can be a normal value, or it could also be null. So non-null, and this means it could be non-null or it could be null, but this is part of the type system. And what's nice is as you get in here, sneak ahead of, yeah, we'll sneak ahead of the next session. So once you get in here, we have that non-null string above and we have the nullable string. If we do non-null string.length, what we're actually executing is I am a string. So we're going to go ahead and get that length 13. I'll move these a little bit closer together so that we can see both at the same time. There we go. So if we went ahead and said this nullable string and we ran this, we'd see the length is nothing. We have this thing in here and it says, hey, we know the value right here is an actual value, but the type itself is a nullable string. So what Kotlin forces you to do is to say, hey, you're either going to use this question mark dot syntax to say that it's a safe way of interacting with the value, where if it's null potentially, or you could say, hey guys, I know this isn't null. Maybe it's something that came back from an API response. Maybe it's another Java library you're interacting with where you don't know, where it doesn't think it's, anyway, you know it's not null, right? It can't be. So what you can do is you can call double bang it, where you do 2 exclamation marks, and you see the compiler was happy now, right? So it's got the red squiggly. I'm going to say, no, I absolutely know this is non-null. In this case, it'll run fine because the value above is actually set. But if I did set this to null, and now I run it, then this length, I'm saying, oh, it's for sure, it's never going to be null. No way. I run it, and then you get a little bit of an explosion. So down here, null pointer exception, the dreaded exception of Kotlin developers, or sorry, of Android developers everywhere, Java developers. There's so many terms. Anyway, they're all the same. So what do? So we use this null tape, the safe access operator. We put a question mark in there, and now we run it, and we get no null pointer exception. We just get that the value is null. The reason why this is it executes up to this point of the null tape operator. If the value below this is null, it short circuits, it doesn't execute anything else, and it returns null. If it is not null, then it says, okay, cool, I'm going to continue and keep operating on. So what's cool is you can kind of keep chaining these things on. If it's not null, do this. If it's not null, do this. But then you're making sure that when you're interacting with something that can be null, you're not going to get that null pointer exception. So love it. Can prevent tons of crashes, because when you know something is coming in and it's nullable, it's going to force you, the compiler, to actually take care of it like this does here. It's like either to know that I for sure know it's not null, or it could be null. Let's figure out what we want to do. Moving along. So when you're interacting with Java, it might not be decorated with null, and if it should be null or not null. So in this case, a Java user, I'm able to create with null and null. And if I execute this, I print out the first name, it's good to go. Null. If I go ahead and print out first name.length, we get another null pointer exception explosion. So this is what's kind of weird about the interop. So there's a solution that you can use though, which is you go into the Java user itself and you add annotations to it. So for this get first name method that we're interacting with, I'm going to say nullable. And then for this one, I'll do the same, get last name. So what happens is, I'm in here, now Kotlin compiler immediately notices, hey, you added this annotation that says first name could be nullable. So now I'm going to force you, before this code compiles, to actually operate with a safe operator. If I run that, it's null because it executed up to this, realized it was null, and then returned. Or since it's first name, I can set that to Bob, run it again, and it's not null, so now it'll execute the length on Bob and go forward. So what's nice is you can add these annotations onto existing classes that are in Java so that from the Kotlin world, you're able to code safely against it. We'll put that back to where it was, make sure this isn't exploding over here still, and move on. All right, moving down. Kotlin functions are fun. I've seen a few talks on that, and it does make it seem kind of fun there. I'm going to talk about what it would look like to have the same method in Java and what it looks like in Kotlin. There's some cheating that you can do with IntelliJ where you can just kind of paste some code over here. That's Kotlin. Didn't do it there. All right, so I'll do it over here. If I was to write this code in Java, I'd say I'm going to return a string. Maybe it's public, right? So public string. I'm going to call it first, last, and then I'm going to pass in a Java user, and then that's about it. So it's really hard to write this now because I haven't been doing Java in a long time. But this method, this syntax for defining a method is equivalent of the one below. So we're seeing first, last is the name of the method. The type you return is at the end in Kotlin instead of in the beginning. And then the way that you define variables, in Java you say the type and then the name and the value, and here you say the name of the value and then the type. If we trust that's how it works, we can then operate with a Kotlin function. So here we're doing a print line on the first, last of that value. We have up top Sam Edwards, and you saw the result here is Sam Edwards. So this is a Kotlin function. The type is going to be returns at the end, and it's a function. One thing that's kind of cool is if you have a void function, something that doesn't return anything. So this method is called just print because it's going to go print, not return anything. It doesn't have to use void. The type that's equivalent to void is called a unit, which is available in Kotlin, but you don't have to say it at all. So I can, the IDE itself, I can use a little code completion tool. It'll just go ahead and get rid of it completely, and it operates exactly the same way. So that's really nice. We can get down here now to a Kotlin extension function. So Kotlin extension functions, really nice because we are able to operate on an object and provide a new method. So let's say that we went into Java user here, and what I'm trying to implement is this, right? So print line, first name, last name. We came over, we'd add a new method here. We'd say, public string, first, last, and then we do a print line. And actually, it doesn't return anything, so we'll do a void. And this would be, oh yeah, this is all, anyway, this is part of the demo. I haven't dry run completely, but the idea would be, let's go back. The idea would be that this is going to operate on a Java user. If we compare to what we had above, put them closer to each other. Compared to what we had above, before we were passing in a Java user. This time we're operating on a Java user. So extension function allows you to add a method to a class and then like have custom logic on it. So in this case, this first last thing now is not only the first name property that we had, the last name property that we had, but now we have this this first last method. So I went ahead and called that, and I run it, and I go ahead and get Sam Edwards. Let's dive into what this really is, though. I wanted to show you in the bytecode. So if I paste this in a real Kotlin file outside of this worksheet and paste it in, I now have this extension function that can operate on a Java user. One of the coolest things that if you want to learn Kotlin and figure out what things are doing behind the hood is to look at the Kotlin or the bytecode that's behind here. So you can go into Tools, you can go into Kotlin, and you can go into Show Kotlin Bytecode. This will show you the equivalent bytecode for the Kotlin that you've written. And I don't know what this means. I could probably figure it out, but like nobody wants to do that. But there's this magic thing called a decompile button. If I hit this, it takes this Kotlin code, converted it to bytecode, and now converted it back to Java code. So what we're trying to do is show that this right here, if a method on Java user that prints first name, last name, is the same as this Java code that's underneath the hood. So what's happening is there's a method called first-last, which takes in a value of Java user. It makes sure that both are non-null by using this intrinsic thing, and then basically concatenates two strings, first name plus last name, and then prints it out. So the functionality is exactly the same as you have in here. It's really nice that it's a discoverable thing. So when I want to find that method, I just say, my Java user instance dot that method. Yeah, it's just a lot cleaner syntax. So moving on. Yeah, so I was kind of mentioning extension functions allow you to add functionality that did not previously exist. So if you wanted to format something you wanted to format a Java user in last name, first name, then you could create this method on a Java user object. So no matter who the user object is, Java user, and then here would be Michael Jordan. And then when I create this object, I now have on here last and first. I'm able to execute that, and I think that'll just show me the result. If not, yeah, Jordan Michael. So it's really cool that now any instance of Java user that I have, I can go ahead and write that on. So extension functions, you can add to Java objects or Java classes, and you can add them to Kotlin. Automagic. This is my favorite word in programming. There's some dependency injection libraries I've looked at in the past, especially the first time I looked at one called Dagger, which is available in Java and Kotlin. But Automagic, or Automagically, is like when code runs, and somewhere beneath under the covers it's going to be making sense and work, but like it's going to take many, many days to dig in and figure out what's happening. What's cool here is this is the Automagic Java to Kotlin conversion, where you can just take a file that's written in Java and just convert it over. So what you can do here is this Java user file that we have, which is that original class, that's Java user. I can literally right-click on it and then go say convert Java file to Kotlin file. I click it, I sign my life away, and I get this. Did you see that real quick? That was a lot of code we had. I'll even keep it around in my clipboard just so we can see. And go back, and here's our Kotlin version. So this is a one-line class versus this class I have below, all this code here. So what's nice is, let's keep it around now. This is functionally equivalent to what we had. So all the code I have up top here referencing Java user actually is going to work, other than the ones that are sending in null values. And the reason is because in Kotlin, I'm specifically saying it's a non-null type. If I do this, it'll make it happy. I can go back to my existing code. Everything will compile fine. But that's nice, the warning's directly in there. So anyway, if you want to convert your code, any Java code you have, and move over to Kotlin, you can do that. This is not a contrived example, but I made it so it like kind of trimmed down to be really pretty code. Because it is programmatic, sometimes you get some kind of dirty looking Kotlin, but it's always functionally equivalent, which is the important part. So you can move it over and slowly take out like best practices of Kotlin code, but it will still be working. All right, that's our Automagic conversion. And then I wanted to show you underneath the hood what a Kotlin class looks like. So I'm going to call this my Kotlin user, so it's not too confusing. This is what this class looks like. I'm going to remove these nullable things. I want to keep immutable data, and I'm going to go ahead and do that same thing we did before. I'm going to show the bytecode, decompile it, and now I have the Java equivalent of my Kotlin user. So this should look exactly like we just had originally. We've got in here 2 private non-null strings. We have 2 getters, just like we had, and then we also have a constructor that takes in 2 non-null values and sets them. So it's literally the same thing that we had. It's just that we, wrote it in Kotlin, and it looks a lot easier. Now, there's something that you can do is you can add a thing called data class to a class. So if I do data class my Kotlin user, it's a keyword that you add on there that when this class is generated, let's look at the bytecode again, it's going to generate more fun stuff for us. Show Kotlin bytecode, decompile, here it is. So now we have all the functionality we had before, the properties, the getters, we have the constructor, but now we have all these things below. And what these do is allow deep copy constructors. They allow hashing, so the ability to do hash and equals, which is important to do comparisons. So you have these 2 data classes. You can just have the two instances and just compare them, and it'll do a direct comparison. And this toString method is really helpful too. So let's do those in use real quick. I have this Kotlin user now. If I try to create that Kotlin user null, it doesn't like me. So let's create one that actually has not null values. And if I want to go ahead and hit play, I think that'll print out the value on the side unless something is broken above. Oh, my Kotlin user. So I'm going to go ahead and just leave these as nullable so the code will continue to compile. Just kind of, when you're doing live demos, things you have to do. All right, so we're down below. Let's see where we were. Don't look too closely while I scroll. We did that right here. So yeah, we have our Kotlin user now. We went ahead and ran it from this point in time. Then my Kotlin user. I didn't do this before. I got my Kotlin user. All right. Why is this a problem? All right, this is not what I was expecting. We'll go back to Java user because that's what I had originally, and hopefully that'll fix it. So you guys get live demos, right? There we go. Didn't crash. Woohoo! Crowd applauses! Yay! Remo, do that feature. All right, another feature request. Down here, we're beyond that. We're right here. Yeah, so now we got this. It prints out on the side here. We have this Kotlin user. But now, if I want to go ahead and print this value out, I can do that right below, do a print line on Kotlin user, and print. And so what I get is this really pretty two-string method. So Kotlin user, first name, last name. Now, if I was to have this be a Java object, or actually if I just have it be a simple class, I don't get that. The data class is really what gives me that nice two-string method. I just get that it's an instance of this Java object, where if I put data class, it's generating underneath the thing, underneath the covers, the copy constructor, it's generating the hash code, the equals method, and it's generating this two-string method. So those are all super helpful. What you can do then is, if you make this a var, we could go ahead and we could set these variables or reset them. You could do this, but in functional programming, you kind of don't want vars. So typically what you'd want to do is create a copy of this. So we're going to get rid of this, and down below we're going to do the equivalent, but using like functional programming style. So what you're going to do is end up creating a new user from this. You're going to take the current user and you use named parameters, they call it, to do a copy. So what this does is it takes this Kotlin user that we have, creates a deep copy of the entire thing, and the only difference will be this. So now if we print out right below it what that new Kotlin user would look like, we can see the first name Kotlin, the first name is first. So it has the differences here, and it created a brand new instance. So copy constructors are really cool, and name parameters are really just the most fun. Because as you get to have many, many parameters on there and have to worry about the order, let's actually find an example here coming up of why that's so important. Name parameters save the day. That sounds like a cool superhero thing. This is a class I came up with to be as confusing as possible. So this is user eligibility. You have is active, can you withdraw money, and can you deposit money? This is all based on some rules engine that you're going to have. So if you look at the code below, if you're to create one of these in Java or normally, you just say user eligibility true, true, true. And if somebody came into your code and did this, it would completely screw up everything, right? So if you change the order of one of these, granted they're all true in this case, but if they're not, then that could really screw things up. So what's nice about the IDE that you use is as I uncomment to this, it realizes Kotlin code and it has the name of the variable. So can withdraw is active, can deposit. If I use that Automagic option enter, then it tells me what I can do. And it wants me to add named parameters to this. So I do that, and then it looks really pretty. So now I know what each one of these is. I'll do a small format. Hopefully that'll look nice. But yeah, now I know a user eligibility object with all these values set to this. You might say, man, that looks kind of verbose. But as I've found, when you're doing PR reviews, when you're looking at code that you didn't just write, this makes things so much easier. And especially when you have to deal with Java code or something that doesn't have name parameters and it's just true, 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 or true, false, true, so many bugs can come out of that. Not compiler bugs, but logic bugs. So super cool to have named parameters. We talked about lambdas and higher order functions. What a higher order function is a function that you can define as a variable. So this might lose people. I know that we have a lot of people that are kind of new to programming or new to this, but what it means is normally you'd have a variable that's like val name equals Sam. In this case, I'm creating a val is active role is equal to this thing. And this thing is something that takes in a user eligibility and returns a Boolean. So it is a function, but it's a function that I can pass around. So I made this rule basically, if you pass an age of eligibility and it's active, then it's going to return true. Same thing with the non-active rule. What I can do down here then is I can use these rules, I can execute them, and what I'll get is it active? Yes. Is it not active? False. Continuing on, if I wanted to use a rules engine, I could actually pass these values along. I have this compute function where I pass in my rule, and then I do a computation on it. Anyway, if I did this here and I have a rules engine so people can pass to me various ways of doing computation, then I can actually invoke those on an object, and then my result is the same, true and false. But this is dynamic, so I could define another rule I pass in here that I have no idea of, but it gives me a very clean way to write code. You really like your enums? I like enums as well. I wanted to tell you that enum classes still exist. So this code, if you went ahead and you wrote it in your, I think I have this little Kotlin temp thing. So if I put it inside of here, that enum that I have in, it basically is going to be exactly like it is in Java. So I can do that same tool thing, show me the bytecode, decompile that, and the result is pretty much exactly the same thing, public enum with eligible and ineligible. Enums are really awesome, but if you've done any Swift, then you know what enums with associated types are. And they are really awesome. What that allows you to do is really associate extra types with one of these enums. So it could be like ineligible, a read-only file. So we'll do it here. So ineligible, but it would also have like string reason. So why is it ineligible? Or maybe we have something else in here, like it just error occurred or something, right? And then I want to have the error, and then I want to keep the E exception. So that would be really nice. That's what they have in Swift with these enums with associated types. We can do something like that in Kotlin, and we can't do something like that in Java. So I'm going to show you what that looks like in Kotlin with sealed classes, which are basically enums with associated values, but done right. So you define a sealed class, which is like defining an enum, and then you define types that extend from that. So both of these are eligibility results. So just think of those two enums, you had eligible and ineligible. That's what these are. And then what's nice is this first one is just an object. It's just been defined. It is what it is. But the second one is actually a class that gets instantiated. It's ineligible, but it gives you a reason why. This is super helpful because as you're processing it, like you can do nice win blocks, which I did down. I didn't do a nice win block there. But anyway, you can do win blocks or if statements on that to make it a lot more readable. So down here, if I have a new rule, basically if it's active, then I can return it's eligible. Otherwise, I could say ineligible and just say, hey, you weren't active. That's the reason why. So the goal of this was to just show up Kotlin field classes. I don't think I show a win block in here, but win blocks are really awesome as well. Let me just show one of those because I like them so much. We'll do it just here. So you can do a win, and then this is a eligibility. So I have one up here already. All right. So if we had a val eligibility, we'll just call that result equals eligibility result dot, and this is very similar to the way you'd see like an enum, right? So you can say it's eligible. If that's the case, then I can have, not knowing what this is, I could have a win statement here. And then for the sake of this, I'm going to call it a one of these. So this way it's typed to the sealed class type and not to the explicit type of eligible. So now I have this, I have a win block down here, and what I can do in Kotlin is say is eligibility result dot eligible, then do this block of code. And then if it is a eligibility result dot ineligible, now what I can do is I can say front line, and then I can say eligibility result, and it does this explicit typecast because it knows with the win statement here, it is ineligible. I now have access to reason. So I forgot my little arrow here, but like the implicit access to what that it knows the type is really helpful. So in this case, if I run it and we made this to an ineligible, and then I do it like I tell my kids just because I said so, then you can go ahead, parenting can be hard. But then you run it, and then the result of this win block is just because it'll operate at this out, and it's an ineligible result. So anyway, just like enums, you have like a win block, you can do that, or a case block. It is in Java, you can do the same sort of thing here. I would love to go into coroutines and reactive programming. I'm just going to tell you what they are, but that's like the big thing that I'm getting into recently. I've been doing it for a while, but I've been trying to like understand it more and more. So I just did a talk last week on something called Kotlin Actors that enables concurrency with coroutines. But that gets way too deep. Let me just go back to the slides now. Hopefully you got some good ideas here of like, how you can convert code from Kotlin to Java and so forth, or vice versa, so that you can understand what the bytecode looks like. You understand like there's nullability in the type system and things like that. So let's jump back and just learn a little bit about, in 1 or 2 slides, what coroutines are, because they're a big reason to come over as well. So I'm not even going to go through these too much, but yeah, the features that we learned about is interop, extension functions, conversions, null safety, data classes to give you those cool toStrings and copy methods and comparisons, immutability, which is big. So writing final on every one of your variables in Java is just not fun. So writing val is much cleaner, and it's more out of the box, I feel like. Name parameters, you don't have to write new or write a semicolon, and then you have these higher order functions and lambdas, field classes, and now coroutines. Those are my favorite features. These slides are directly pulled from last week, sorry about that. But I tried to explain it in 1 slide, so that's why I thought this was important. It is another Kotlin function, but it has a keyword suspend in the beginning. And what that means is it must run inside of a coroutine. And then in order to run code inside of a coroutine, you have to launch it in a coroutine context, which is like kind of like almost like the thread pool it should run in, but coroutines manage the coroutines that are running, which makes it more performant. So essentially, coroutines are lightweight threads that get managed by the coroutine framework. So when they aren't executing, they're just not taking up a thread. So normally if you're running code and you're like, let's say waiting for a response, your thread is completely blocked. With coroutines, it will, when you get to a point where you're waiting, it'll actually be able to use that same thread to execute other code. So coroutines are really awesome for that. And this must be launched in a scope, which says when it should start, when it should cancel, and the dispatcher in there tells you where it should run. That was way too much. Just wanted to get there if you knew what it was. All right, we're wrapping up. Developer happiness, or what do we got? So happiness is real. So if you go ahead and develop apps with Kotlin, I think there was a stat that just came out during this 11 weeks of Android that said that I think 70% of the top apps are written in Kotlin now. But really, everybody I've talked to that writes at least Android code that went to Kotlin loves it. I know a lot of people that have gone server side as well, that I've had to deal with Java in the past and have gone to Kotlin and just absolutely love it. The reason why that most people would say just off the cuff, less boilerplate, concise and readable code, null values are handled proactively, and you don't have to throw away your Java code. This is the biggest thing if you're a Java developer right now. All of the code you've written, you don't have to throw a line away. Just like you kind of saw there, we add in 1 Kotlin file, and then if you add in the Kotlin compiler with plugin, you can access all of your Java code. None of it gets thrown away. You can do bits and pieces. If you just want to try Kotlin, you can try it in your unit test to see how it works. It's not going to affect your production code, but you don't have to throw it away. That means every single library, whether it's something like Spring or like it's a CSV parsing library or whatever it happens to be that's already written in Java, you have access to all those, right? Like it doesn't have to be written in Kotlin for you to use it. So it's just a big win that like it's a very safe thing to try out. And once you get in here, I think you'll find the things that I've been mentioning are really awesome. Also, one of the things that was hard with Java is functional programming. I'm not a purist, but there are a lot of great things out of it that Kotlin just makes it easier to do and makes those concepts easier. So I definitely recommend it for that. And reactive programming, like I mentioned, they have coroutines, which lets you do background work and lightweight and things that are like lightweight threads, and those are super helpful. So Kotlin Adoption. I pulled these stats yesterday. The stats from the that I had previously on this internal version of the slides show, Kotlin adoption inside of Capital One. And basically, Kotlin adoption is growing. We'll just say it like that. But inside of here, these are repositories on the public GitHub. So you can click on these links when I publish the slides. These are the number of repositories created in 2020 of Java and of Kotlin. And if you see, there's been 1 million of Java, about 100,000 of Kotlin. So that's actually really amazing for where we are right now. So if I actually compare the numbers further back, and they're not nearly as close. So it's really neat that in 2020, there's really a big push on Kotlin. I don't think Java's ever going away, but the people that we can bring over to the Kotlin world, I think will really appreciate it and get to keep contributing to that ecosystem in a lot of ways. So what else is possible? We've talked a lot about the Java side of things and the interoperability with that. You don't have to go run your code on the JVM though. You can use things like Kotlin Multiplatform, which allows you to target. I can write my code that runs on the JVM on Android, but it compiles down to Objective-C bytecode, which is accessible via an iOS developer. So I can write code as an Android developer, write it in a Kotlin Multiplatform library. It goes ahead and then exposes that to an iOS team. So there's a lot of back-end logic that you can do in that. Multi-platform code can be hard, but there's a lot of benefits you can get from that. And a lot of people are using it successfully in production. You can target things like JavaScript as well, Mac, Linux, and Windows. If you use IntelliJ IDEA, it has like some new project wizards that can help you set up multi-platform projects, and there's some cool resources online. To go along with that, if you want to write purely multi-platform code, there are libraries for networking called Ktor. There's Kotlin X serialization for serializing and deserializing like JSON and responses. There's SQLite, which I've done talks on, which it allows you to interact with databases. So on Android, it might be the local SQLite thing. If it's running on a back end, you might actually want to go talk to a Postgres database or something like that. And if you want to do dependency injection all over the place, I've done talks on manual dependency injection, do it yourself. That's a really good method. But if you want to use something more structured, Coin is this little like icon, like a Pac-Man, Koin. So you can use that as well for dependency injection. And this link below has pretty much a really cool list curated of some cool multi-platform libraries. If you're worried about, if you're wanting to leave Java because of speed concerns, I don't have a slide in it for this, but there's a thing called GraalVM. And if you haven't heard of it, it's basically a way to take Java bytecode during the compiler process and bring it down to native instructions. So what native means is you're having code that runs on the CPU architecture. So that's maybe an x86 architecture or an ARM architecture or something like that. But that code has to be compiled for that specific architecture of the actual CPU that's going to be executing it. The thing that's cool about Java is you write your code in one way, but then the Java virtual machine is actually coded for that CPU architecture. So with Kotlin native, you're able to write Kotlin code that does not compile to Kotlin. It compiles directly to machine executable instructions. And so this gives you a lot of performance improvements by interacting directly with the processor and low-level APIs. I was going to say, though, is if Java is your problem, too, there's a thing called GraalVM that you can actually leverage, which compiles it down to native code. And I've seen crazy speed improvements on that as well. So this is like an evolving space, but people are kind of like, the JVM is kind of slow sometimes and a little bloated. So there are things you can do to take that code and not throw it away and use it. But there's not all roses for Kotlin, of course. No love is perfect, but it's okay. So it's not all roses because there are libraries that are written in Java that are not ideal to interact with Kotlin. So if we thought of a library that didn't have those nullable or non-null annotations, when you interact with it, you may be getting a null value when you weren't expecting it. And so that's one thing there. Also, there's a lot of annotation-driven development, I feel like, kind of a term I've heard in Java. And if that's the case, then it might look kind of weird in Kotlin the way you're doing it, but it's all possible. Really, it depends is the answer for any question, like whether you should use something or not, but is it the right tool for the job? Don't, put a round peg into a square hole or however that works. Square peg into a round hole. Another thing is not everybody knows Kotlin yet. So, how am I going to hire a team? How am I going to do that? And my whole argument there is it's super growing. It's completely interoperable with Java. And if you're comfortable with Java, it's pretty easy to pick up Kotlin. So I'm skeptical. I guess I'm not skeptical. I'm hopeful that it's going to continue to grow. So while people say that now, I don't think they're going to say that in a few years. And I don't think even a lot of people say it now. And finally, it just might be too risky, right? Oh, we don't want to try something new, but it's really not. Like once you go in there, you add the one plugin in and you're done. So I love Kotlin. And I wrote a letter to Java because it was special to me. Java, you taught me about null pointer exceptions, verbose code, and mutable data. I will always love you. But I've met a language named Kotlin and I'm moving on. Love, Sam. The end. Thank you.
All right. That was awesome, Sam. So we have questions, most of them from me. So if you want to take them and start addressing them.
So I can see them on here. On the Q&A tab, it's on the right side next to your chat. It's got 2 votes from the first one. It says, did you have to unlearn anything from Java to be effective at Kotlin? It's been 3 years now that I've been fully immersed into Kotlin, so it's hard to remember those things. But the thing is that you'll see is if you write Java and then you start writing Kotlin, what people say is you start writing Java Kotlin, which means that you're using the kind of paradigms and things that you learned in Java going over. But I think there's a shift. People call like idiomatic Kotlin, and I think people are still figuring that out. But that means leveraging the language and all of the features for what they're really good for. And so I think as you leverage those, I don't think you have to unlearn things from Java, but I think you have to learn more things about Kotlin to just make your experience that much better. So I don't think I have to unlearn anything. I have to think I have to learn more things about Kotlin. That's my answer there. The other question is, can beginners start with Kotlin or do they need to learn Java first? I'm going to say that so the whole thing is having a community behind you, right? That's why we're here today, like sharing information. If you don't have people that are putting out a ton of information on something, then you're not going to be able to learn it very well. And so I think if you're a beginner, it's not the best place to be. However, if you look in the Android space, it is not a beginner thing. So I would say if you are becoming a server-side developer, I would not start with Kotlin. I would start with Java first because of the documentation available. But if you're starting with Android, there's so much content out there, and all of the tutorials and instructions are out there written in Kotlin. I would highly suggest if you're learning Android to learn Kotlin, and hopefully you don't even have to worry about Java too much. So that's the case at this point in time. I would learn Kotlin first. Otherwise, yeah, Java. Next one is, do other IDEs have plugins for Kotlin? Can we just use the IntelliJ Community Edition for Kotlin? I haven't used other ones, but yeah, there's tons of other IDEs that can go ahead and do that. I use Visual Studio Code a bunch just for text editing, and it does highlighting. My blog as well, like, does Kotlin highlighting. It's just something that you can parse. I don't think there's as many like nifty features. Like I was showing you the option enter sort of like magical things that come up, and I think those are things built into the IntelliJ IDE. So I don't know if anybody else can match the amount of tooling that they have in there. I mean, this could be similar about any other language you're writing. Like, it's hard when you get out of the platform built for it to go somewhere else and have those benefits. So you can definitely use the community edition. I have the professional version just because I have it. But you can use this community version, and it has all the bells and whistles for Kotlin there. I think that the differentiator features are things like very, very like kind of high level enterprise things that you're not going to need to learn Kotlin. So you can definitely use the community version there. And like I said, the Android Studio is actually built on the community version, so it's just kind of extra stuff added on to IntelliJ community. Let's see. Are there linters or sonar profiles for static analysis for Kotlin? All right, yes. There's klint and there's detect with a K. Everything has a K in it. But both of those we're using, they're enabled to detect lint issues. They're able to detect other style issues and things that we're not wanting there. For static analysis, I actually have some bonus slides I'm going to pop back into. I was like, I don't know if I want to, but it's pretty much just documenting the, right here, right at the very end, because I literally had it. It's saying that process that we went through where, you know, we had Java code, or we had Kotlin code, we showed the bytecode and generated Kotlin code. I want to show you like what's happening behind the scenes, because when you're talking about static analysis, there are some gaps between support for Kotlin. Not everybody has it, but everybody has Java support. So what you can do is you can do some conversion. So if you have your code in Kotlin, you run it through the Kotlin compiler to generate Java class files or Java bytecode. What you can do though is once you have that Java bytecode, like we saw on the side there, you can decompile that using a Java decompiler to a Java source file. You can do this using a tool called Fernflower. It's actually the engine that runs in IntelliJ behind the scenes. So if you look, there's this, you can just look this up online, the Java decompiler inside of IntelliJ community. This exists. You can bundle the jar in there, and you can basically just, compile the jar and execute against it. You pass in a bunch of Java bytecode, and it generates out the Java files for you. So if you're doing static analysis and Kotlin isn't supported, you can do static analysis of the Java equivalent of it, which like, it's literally coming from the bytecode, and so it is equivalent. And so from a security perspective, that would be totally fine. So the magic is you have your Kotlin, you go ahead through Java bytecode and decompiling, and you have Java. So if you need to, you can go ahead and do any of your static analysis with that. Next question, are there any libraries like ORMs for Kotlin? I mentioned SQLDelight is one. It lets you do that, so that allows you to write out your SQL statements. It generates type-safe Kotlin code, which is an object mappings for that, so you can do it there. If you're doing things in Java, you can tap directly into other ORMs that are available. I'm not too familiar with the ones, there's probably Spring ones out there, but you can tap in any one because you can just leverage Java code. Next one is by Alec, saying, can you use it to make an API? Absolutely. So anything you can do in Java, you can do in Kotlin. An API pretty much just means that you have a web server running. So I think there's some simple web servers that you can run just for Kotlin. I think it's part of KTOR actually. You could spin up a web server. If you just wanted to write it in Kotlin, you could do that. Or you can use a web server like Jetty or something else on the Java side and write your Kotlin code to do it. So definitely. Has your writing style turned more functional after switching to Kotlin? 1000%, Shalom. Yes. Like I'd heard of functional programming and it was this weird thing. Like, people talk about it and from where I was at the time, it seemed like this kind of very intellectual thing that I would never understand. And the talk last week, actually after mine, was talking about result monads. And even the term monad now, in my head, it still seems like something that's so so hard to understand. Although it's just not something that I feel like I can explain to somebody very easily. But there are concepts of functional programming that you can do in Kotlin that really help, like custodial classes, like immutable data, like things like that are core to functional programming that enable you to get a lot of those benefits. And so, yes, it does help me enable that, but it does it in a way that I kind of don't know I'm doing that. As I've gone along, I realize what they are. But I think it enables people just to write better code, I think is what it's going to do. Last, which software engineering specialties are adopting Kotlin besides Android development? You may have missed this. Yeah, so I was kind of saying, a big thing is server development. So as part of the Kotlin GDE program that's there's definitely a big push to expand into the server-side world. Like I said, we just got Josh Long, who is a DevRel at Spring. James Ward is a DevRel from Google that writes tons of tutorials on this stuff. Google Cloud Platform supports Kotlin natively. And so there's just a big push. So anybody that's writing content for Kotlin, reach out to me and I'll make sure I share it with the channels. And if you have the right experience, maybe you can join the GDE program too for that. I think that's all the questions.